Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new concept regarding the head of hydraulic turbines. So in our last lecture, we have seen the working principle of a hydroelectric power plant, and we have discussed that how it is working and how the potential energy converted to electrical energy. So just I'll give a recall of this. The same diagram we have taken in our last lecture to understand how the what is the working principle of this hydroelectric power plant. So in this hydroelectric power plant, we need to take some kind of equipments are there. Like we need to construct something. So this is a dam is there, and this dam is nothing but to store the water. And from this dam, through the help of this penstock, the penstock is nothing but a pipe. Through this pipe, the water will be flows through this one, and at this end, here one valve will be there, and at this nozzle point, the water will be come out from here from this pipe or penstock, and it is going to strike to the turbine. So due to this high velocity of this water, and these are the in the turbine, this is called a runner. This is called runner, and this is actually shaft, and these are the vanes or buckets, and this is whole total is called turbine, and the shaft will be connected to the again it will be connected to the generator. Okay, so these are the equipments are there, and once the water of this from the dam, the water which is coming out from the dam, it strikes to the turbine, then after that it will be falls to this container, or that is called sump level also, and you can say this is tail race. That means the water came from this after striking, it will be stored here. So this is the process of like hydroelectric power plant. Now when the water is stored at this time, that water is actually in the it is in the potential energy. Okay, and when the water is flowing through this pipe, this is called here kinetic energy. Okay, kinetic energy, or the water which is striking at this point also, that also we can consider this is your kinetic energy. After striking, it started rotating. Which one? The turbine started rotating. So that rotates, that turbine rotates means it's converted, this kinetic energy converted to what? It is mechanical energy. Rotation is there. So the shaft rotating, see, once turbine rotated, then the shaft also started rotating. So shaft is connected to this generator. So now this mechanical energy which shifted to generator, so here the electricity will be generated. So this is electrical energy. So you can see the process, like how many processes are there to convert a hydraulic, like to create hydroelectricity or hydroelectric power plant, how to generate. So here we'll discuss what is the head of turbine. So head of turbine, actually, if I'll define this head, this is nothing but, if you call it a head of turbine, or it can be called as a hydraulic head also. So the hydraulic head is the height of water. The height of water, if you consider this is the height of water, okay, uh, above the inlet of the turbine. So this is the inlet of the turbine, if you suppose the distance or height, you can say. So this is nothing but, we can call this is the height of water. The height of water from the turbine inlet or above the turbine inlet. This is the turbine is there. From this inlet to the at what level the water is present, at what height the water is present. That is called head. And this it is denoted by, actually we can say it can be denoted by, sometimes it used to write capital H, and somewhere it will be written also small h also. Okay, and this, as I told you, this is the height. That means the dimension of this will be, the unit will be considered as the meter. Meter can be taken, or somewhere it will be given in centimeter and millimeter also. So these all are accepted. Okay, so this is about the head, or we can say this is the difference between the source, the water source. It is the difference between, you can say, the water source. The water source in the sense that up to what level the water is present, that is called head water. It is called head water. And the turbine tail, the turbine. So turbine is nothing but, it is in the tail race. This is head race and this is tail race. The same thing we'll discuss while discussing the gross head, I'll tell you. Okay, and this is about head. So this head is, it's divided, it is of two types. if you discuss about the types, it is of two types. One is gross head. One is gross head. Another one is net head. You can see this is one gross head is there, and another one is net head. These two are there. So gross head, another one is net head. So first we'll discuss about the gross head. First one we'll discuss about the gross head. So gross head actually it is denoted by Hg. As you can say like head equal to H and G for gross. So this one indicated by Hg. Here also it is given, you can see gross head. So what is the gross head? So it is very simple. It is the difference between, we can write, it is the difference between, this one we can write, this is the difference between, you can see what is the difference? The headrest from this height to this height. That means the height between the headrest and tail rest, or we can say the difference between headrest level and tail rest level So this is the difference between, like at what is the distance or what is the difference between the headrest and the tail rest, that is called the gross head. But at which condition we need to consider? When there is no water is flowing. This is important, when no water is flowing. That means when the water is in a rest condition, we need to consider, we can identify the gross head. Okay. And second one is net head. So this is also simple, but let's slightly need to understand. This is net head, which is denoted by H, this one. Okay. So net head actually, it is also called as effective head. How much effective head is there in the turbine? This is also called net head or effective head. So this is actually the head which is available at the inlet of the turbine. The head at the available at the inlet of the turbine. Either you can consider here, or sometimes the turbine used to inside the water actually. So we have considered from this tail rest to up to a distance of this. So why this distance is removed or not considered, I'll tell you that. So the distance between, or you can say the head which is available at the inlet of the turbine. So when the water is flowing, this one we have not considered when no water is flowing. Now this one we need to consider when water is flowing. And we know that when there is a fluid flow conditions will be there are some losses will be there. So when the water is flowing from the headrest to the turbine, from the headrest, like this is the headrest. So obviously the water which is present here, the water started flowing from this. Now when the water started flowing through a pipe, we know that there is some kind of losses of energy will be there. So that is called losses of head. So loss of head. So when the water is flowing, the loss of head. And why this loss of head will be there? The friction between this pipe or this penstock and the water. So loss of head, this is due to friction. Between the water and the penstocks, because obviously when the water will be flows through a pipe, we have seen our losses. If you see the video, losses of energy. Okay, one is major loss, another one is minor loss is there. So this loss of head due to friction, this is coming under the major loss, and this is coming under major loss. And another one is there minor loss. So minor loss is due to some kind of bendings. If you see here, some bends are there. Okay, so bending in the pipe. If suppose I told you some valves are fitting here, some valves are there to control the fluid flow. So valve fittings. Okay, so these are the things will be coming under minor losses. Okay, these are the coming under minor losses. So minor losses will be not that much effective rather than the major loss. So major loss is more important, and this major loss, due to these losses, the loss of due to this friction, the loss of head will be occurred, and that is coming under major loss. Okay, and this one we have to mark as a HF. the loss of head. This one we can mark it as a loss of head. And as we can see, because the minor loss is very small, so we can ignore that. Okay, so if this HF, you can consider this is the loss of head due to friction between this penstock and the water. So the net head, that means due to the, if you remove the loss, there we can find out the net head. So here the net head will be calculated. The total head, how much was there? This was the total head, the gross head, that is Hg, minus this is HF. So this is the net head. And how this HF will be calculated? So HF actually, it was derived in our previous lecture, that is Darcy-Weber's equation, that is measure loss. And there we have found one equation like 4LV square by 2dg, right? 2dg. This is the measure loss equation or Darcy-Weber's equation. Now here, what is the F for friction factor will be there? V equal to velocity, D equal to diameter, and L is the length of the penstock. So V is the velocity. So all the terms we have seen previously. So these are the gross head and net head explanations. And how to calculate this one also we have seen. Now thing is that another question is coming here. Why this use, or what is the application of this head of turbine required? Why this head is required? If you talk about this, I'll write one its uses. What is it required? Now when you select a turbine, because this is we are discussing about the turbine, okay, head of turbine. Now when you select the turbine, because we in a future lecture we'll see what are the different types of turbines are there. There the turbines will be categorized according to the head in the sense height, at what height which kind of turbine will be used. So selection turbine, it will be required. Selection in the sense, if you tell me in details, like we are having Pelton turbine, Kaplan turbine. So number of turbines are there, like Pelton turbine will be there, Kaplan turbine is there, and Francis turbines are there. So these are the three different types of turbine mostly used, and these three different types of turbines are having different heads. That means as per the different height, we need to install this kind of turbines. So when the selection of turbine required, so head is most important to understand. And similarly, while you calculating the power, calculation, okay, in that also we need to see what is the head, because P equal to rho G QH, that formula is there. So while calculating this one, we need to know the head. Okay. Similarly, while efficiency optimization, because power calculation is there, means we need to next we'll go for the efficiency optimization or efficiency calculation. Now how to optimize the efficiency? So by knowing this head and the applications, we can see what is the how to optimize the efficiency. These are the uses are there. Even if you tell me the application of this, where we can use, what are the different kind of applications will be there, then I can say the hydropower plant design. Okay, if you are designing something hydro power plant design, then obviously we need to see what is the role of this head. Okay, this is when you are talking about the hydropower plant design, then obviously we need to see what is the head, how much height is present. So we need to see, then only we can go for the construction of that. Okay, because what is the dam height is required? See here, one dam is there. So how much height should be there from this ground level, from this reference line, or you can say from the tail race, about distance will be there. So choosing the dam height is required, what kind of turbine will be used in that, and what is the penstock length will be there. So designing of hydraulic power plant is very much important to know the head. Similarly, in the water resources department, if you see, okay, or we can say the water resources design, here also we required the help of this head, because to determine the energy potential of the river. So what is the potential of the energy, and what is any kind of waterfall is there. So to identify the energy potential for the waterfall, we need to know about the head. So it is very much important. Even many more applications are there, but I think this is okay. You can understand what is the head of turbine. And if you want to just summarize this one, first one is the head definition what we have given, and you can understand this is nothing but height of water, and it is denoted by h, or small h also can be given. Now this is unit is meter, and two types are there. One is gross head, another one is net head. And gross head is nothing but Hg, and that is the difference when no water is flowing. And net head is actually, this is gross head, and another one is net head. And when water is flowing, we need to consider, and that is the difference between the total head, like you can say this is total head minus the losses which is happened between the headdress and the turbine inlet. So these are the losses we need to consider. So, and these are some applications uses are there, and this is the head loss formula. I hope you understand this lecture. If you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.